Hello, welcome to the Day 8 Notes, Section 6.5, Solving Polynomial Equations. Today we're actually not going to be solving, we're just going to be factoring the polynomials. Tomorrow we're going to go to solving. So like quadratics, some cubic polynomials can also be factored with special rules, and those two rules are sum and difference of two cubes. So if you have a sum of two cubes, the first term here has to be a perfect cube, the second term here has to be a perfect cube, and if they are, then it can be factored, and the way we factor it is it's always going to be a two-term factor, a plus b, and it's a plus because we have a plus here, so this first term will always have a plus, and then you have b times b times b. And the way that we figure out how to factor that, the second part, this trinomial, try because there's three terms, you take the first two terms, multiply them together, and that product goes there, and then the second two, so here we have a times b, that product goes there, and then the last two, b times b would be b squared. So now to figure out the signs that go with that, if the last term is always going to be plus b squared, and then this term is going to be the opposite of what's in here. So if the first binomial, that a plus b, the second sign is going to be a minus. Okay, so now a difference of two cubes is the same idea. You would do a times a times a, and then b times b times b. First product or first factor is going to be a minus b, so you just uncube them, and then the minus sign matches this minus sign, and then this trinomial here, you're going to do a times a is a squared, your first term, a times b, your second term, and then b times b, your third term. So like I said, this sign is always going to be a plus b squared. If the first factor has a minus sign, this sign is going to be a plus. All right, let's take a moment to talk about the first few perfect cubes because you are going to have to recognize them when you see them. The first one is 1 because 1 to the third would be 1. 2 to the third is 8. 3 to the third is 27. 4 to the third is 64. 5 to the third is 125. 6 to the third is 216. And 7 to the third is 343. If you're ever uncertain whether something is a perfect cube or not, you could check using your calculator. You would press the math button, which is underneath the green alpha button, and then it's option 4. So say I had something like 100 and I wanted to see, is that a perfect cube? I would press math 4, put in 100. If it's not a whole number, then it's not a perfect cube. All right, so let's take a look at example 1. We're going to factor each polynomial, and if it can't be factored, write prime. So let's look at example, or the first one, 8x to the third plus 27. You always want to first check if there's a greatest common factor, something that will go into all the terms of the polynomial you're factoring. 8x to the third plus 27, there's nothing that can be factored out. So then I look to see, is this a sum of two cubes? 8's a perfect cube. X to the third is a perfect cube, and 27 is a perfect cube, so I can factor this using the special rule from above. So I'm going to break up 8x to the third and see what it was before it was raised to the third. Well, it's 2x times 2x times 2x, because if I multiply that together, I would get 8x to the third, and then 27 is 3 times 3 times 3. So now following the factoring rule from above, I'm going to have a binomial times a trinomial. In the first parenthesis, you do a, which we said is 2x. Because this is a sum, I'm going to have a plus sign here, and then b, which is 3. For the trinomial, to get the second part of the factoring, you would take the first two terms, multiply them together. So 2x times 2x is 4x squared. Then I circle the next two, I would multiply those, you get 6x, and then the last two, 3 times 3 is 9. So now we have to figure out the signs that go here. This is always a plus, and then this second sign between the 4x squared and the 6x is always going to be the opposite of what this is. So if that was a plus, we have a minus. And we are done because this cannot be factored further, this trinomial. All right, let's take a look at example B. We have 5y to the fourth minus 320y. Remember, the first step, you always want to look for a greatest common factor. So first, let's look between 5 and 320. Is there something that goes into both of them? Hopefully you see that it is 5. And then we have a y to the fourth and a y, so we can take a y out. So what I would be left with is y to the third minus 64. So once you factor something, you always have to double check and make sure that each factor is, nothing else can be factored out of there, that they're prime. So hopefully you also see that the second term here, y to the third minus 64, is a difference of 2 cubes. So we're going to break it up into y times y, and then 64 is 4 to the third, so it's 4 times 4 times 4. Okay, so my final factorization, that 5y, I have to bring it down. Anytime you take out a GCF, don't forget to include it in your final answer, because remember, factoring is not changing the polynomial, it's just rewriting it into something times something. So like 12, if I wanted to write it as factors, I could write it as 3 times 4. I can't just get rid of that 3 and say, oh, it equals 4. All right, so now the first parenthesis is going to be y minus 4, because it's a minus b. Second one, the trinomial, we circle and multiply. So it's going to be y squared. 4y is our middle term, and then 4 times 4 is going to be our last term. Now we just have to worry about the signs. Always a plus at the end, and then if this is a minus, we're going to put a plus right there. Remember, you could always check if you factored correctly by multiplying it back together and seeing if you would end up with your original polynomial. All right, for part C, I'm actually going to not do this one because this was prime. I don't want to do primes because you're not going to see them on assessments, or you'll see them sometimes in the homework, but never on a quiz or test. So I'd rather just practice ones that can be factored. So say I had 64x to the third plus 125y to the third. Okay, there's no greatest common factor because we have 64 and 125. Nothing goes into both of those. And so then I'm going to check if all of these are perfect cubes. 64 is a perfect cube. It's 4 to the third. X to the third is a perfect cube. 125 is a perfect cube because it's 5 to the third. And then y to the third is a perfect cube. So I'm going to break this up. We have to figure out what is a. What raised to the third power was 64, or gave us a result of 64x to the third. And that would be 4x times 4x times 4x. And then I do the same thing for 125, y to the third. What b value, what was b before it was raised to the third and became 125y to the third, and that's 5y times 5y times 5y. All right, so we have a sum of 2 cubes, so that means a binomial times a trinomial. A plus b is in the first parenthesis, and then the second we find the products. We circle. 4x times 4x is 16x squared. Middle term is going to be 4x times 5y, which is 20xy. And then the last term we do 5y times 5y, which is 25y squared. Last thing we have to do is just figure out the signs. Always a plus. And this is the opposite of what that first binomial sign is. So if it's a plus in the middle, we put a minus. And that's our final answer. All right, for part D, I would like you to pause the video and attempt that one on your own, and then check your answer against mine. Okay, so here's the answer, and hopefully you got that on your own. All right, so we're not only going to be factoring sums of 2 cubes and differences of 2 cubes. There's going to be all different types of factoring of polynomials, so we have to go through all the different techniques. The first thing always, so here's the hierarchy of factoring. First thing you always want to do is GCF. Don't forget about the GCF. That's commonly forgotten. Once you have a GCF or don't have a GCF, then you have to look and see how many terms you have. If you have 2 terms, there could be 3 things possibly, that 3 different rules that you have to remember. So difference of 2 squares, we did this in chapter 5. If you have a squared minus b squared, factors into a plus b times a minus b, and then we have our 2 that we learned today. If there are 3 terms, depending how you learned it, but this is where you would split that middle term or do the box method, or some people call it the product sum method, where if you have ax squared plus bx plus c, by splitting the middle term, you find factors of a times c that have a sum of b. So you would always multiply that first and last number. That's your factors. You're looking for factors of that product, and then they have to add up to b. And then with 4 terms, if there's 4 terms, that's when you group the first 2 together, take out a GCF, group the last 2 together, take out a GCF, and you factor it in that way. So let's take a look at example 2. We're going to factor each polynomial, and if it cannot be factored, write prime. So remember, first thing you always want to look for is the greatest common factor. For example, a, we have 15a squared b minus 10ab. So I do see that they have a common number. I could take a 5 out of both 15 and out of 10, and then the first term has an a squared, the second term has an a. You always take the smaller power, so because they both have an a term, we take out the smaller power, we'll take out an a, and then the first term has a b and the last term has a b, so we could take out a b. Alright, so now we're deciding 5 times what is 15? That would be 3. A times what is a squared? It's a. And then b times b is b, so we don't have to worry about that. And then minus 5 times what is 10? It's 2. And the a is taken care of and the b is taken care of. Looking at these two factors, that can't be factored. It's a one-term monomial. Can this be factored more? 3a minus 2. No, it cannot. So we are done. All right, let's look at example B. It's 3x to the fourth plus 8x to the, or it's not x's, they're t's, 3t to the fourth plus 8t squared plus 5. All right, first thing you want to look for is the greatest common factor. 3, 8, and 5 don't have one. The last term doesn't have a t, so there's no GCF. So going down on the hierarchy, we have 3 terms. This means we're going to have to split the middle term, or if you do the box method. Now, I do want you to notice this is t to the fourth. We've never done a fourth power polynomial. We've done things to the second power, but this is identical to what we've done before. So we're going to do our little table. You multiply a times b, it's 15. So we're looking at two numbers that multiply to be 15 and add up to the middle number b, which in this case is 8. So factors of 15 are 1 and 15. That will not add up to 8. 2 doesn't go in there, 3 and 5, and those do add up to 8. So then just like before, what we're going to do, you rewrite the first term. So in this case, it's 3t to the fourth. Split this middle term to 3t squared, because our middle term is a square, plus 5t squared plus 5. If from habit from chapter 5, if you rewrite those middle terms with t's, it's not going to factor out nicely. So please make sure that when you rewrite that middle term, you do write the variables to the second power. All right, so now we factor by grouping. Let's group these first two together, and we take out their GCF, which is a 3t squared. We would be left with t squared plus 1. And now let's group those two together. It's a plus sign here, so we put a plus sign, and then they have a 5 in common, and it's t squared plus 1. So now we take the outside terms, 3t squared plus 5, and then the binomial that's in the parentheses, so in this case t squared plus 1, that's what they have in common. So it's like we factor out a t squared plus 1, and you'd be left with 3t squared plus 5. Now the thing that's going to happen a lot in this chapter is once you factor, you're going to be able to factor possibly more. So you look at 3t squared plus 5. Can you factor that anymore? No, it's 2 terms, so we're looking for a special rule from above. It's not a difference of 2 squares or a sum or difference of 2 cubes, so we can't factor that further. And then t squared plus 1, there is no such thing as a sum of 2 squares. It's only a difference of 2 squares, so because there's a plus sign there, we can't do anything more. So our final answer is 3t squared plus 5 times t squared plus 1. Okay, example C here, we have x squared minus xy plus 2x minus 2y. Looking for a GCF, there's no variable that all 4 terms have, and there's no coefficient, no number that we could take out other than 1 that all 4 terms have. So we go down that hierarchy, and we have 4 terms. 4 terms we factor by grouping, so we're going to group these two together. What goes into x squared minus xy, and x does, and then x minus y. And then what goes into these next two, because this is a plus, I'm going to take out a plus, and we take out a 2, and it's x minus y. I should have mentioned in example B that the things that are left in the parentheses, they have to be identical, because that's what the 2 terms have in common. So it's like you take out an x minus y, and then you are left with an x from the first term plus 2 from the second term. Neither of these can be factored more, so we are done. Okay, please go ahead, pause the video, and attempt part D on your own. The answer you should have gotten is 2x plus 3 times 3x minus 1. And again, so it was 3 terms. You could have done the box method if some of you are more comfortable with that, or splitting the middle term. If ever you're in doubt, don't forget that when you factor a polynomial, you can always multiply the factors back out and see if you would get the original polynomial. So here, you would do 2x times 3, x giving you 6x squared, and then minus 2x plus 9x, and then minus 3. Notice that if you combine these two, you would have plus 7x, so it is the original polynomial. So you could always, always, always check your answer. All right, part C here. We have 81x to the fourth minus 256. Looking for a GCF, there isn't one, so we have to see, we have two terms. Is this a difference of two squares? Is it a sum of two cubes or a difference of two cubes? Well, because we have an x to the fourth, it's not going to be a cubic, so we're going to check if these are all perfect squares. Is 81 a perfect square? It is. X to the fourth is a perfect square, and 256 is a perfect square. So you can break this down just like we did with the cubes. You'd have 9x squared times 9x squared, and then 256 is 16 times 16. So difference of two squares, remember it's a plus b times a minus b. So a plus b and a minus b. Because we're doing higher polynomials, so this one's to the fourth, you always do have to check if that your factors are completely factored. So 9x squared plus 16, there is no sum of two squares, so that one's good. But 9x squared minus 16, that's still a difference of two squares, so we could factor this, and it would be 3x plus 4 times 3x minus 4, because 9x squared is 3x times 3x, 16 is 4 times 4, so that's why we were able to factor it, because there's a minus sign there. If they were both plus signs, we would not be able to factor it. And then do not forget your first factor, then 9x squared plus 16, because if you forgot it, if you were to multiply back out, if you only had this left, you would not get your original polynomial. You'd be back to 9x squared minus 16. So this is our final answer. All right, once again, pause the video and attempt F on your own. Here's the answer that you should have gotten. If you didn't, please make sure to find out tomorrow in class what you did incorrectly. Thanks. Have a good one.